Hi gang, we're on number 69. Now I asked you guys to do this on the test and the final the way I did this in class. So no matter how they ask in the book, I asked you to please follow how I showed you in class. So how I showed you in class was that I'm looking for three particular parts to the solution. So the first part to the solution, since we know we're going to use the intermediate value theorem, I asked you to write that the function is continuous on the interval. And the reason why we have to write that is because you cannot use the intermediate value theorem if the function is not continuous on the interval. So I would not give you that case, because if I gave you that case, you wouldn't be able to solve it, right? I'm going to give you something you can solve and show me you know what you're doing. But just to be clear, this function in and of itself is always continuous. It doesn't matter where you cut it, because this is a cube. So this function will always be continuous, but some functions you might just, the function itself might not be continuous, but you're cutting it on a segment that is. Now they're asking you for a 0, and just as a reminder, if you forgot the language for that, that means that's an x-intercept. That means they want y to be 0. Okay, so we did the first condition. Now let's do the second thing that I asked you to do. So the second thing is that you have to find the output values, right? Because this is the interval, meaning this is the first x traveling to the second x, right? This is the span that we do. This is the x to the x. That's the cut on the interval. So you need to actually find the y value for those x values. Okay, so 1 cubed is 1. 1 times 2 is 2, so this is 2 minus 3, which is going to be negative 1. And you do the same thing for the 2. Two cubed is 8. 2 times 8 is 16. We'll subtract 3. We're going to get 13 for that. Okay, so what that means is that you're cutting the graph from 1 to 2. Okay, so you're cutting this graph from an x value of 1 to 2, and we know that the heights go from -1 to 13, and since this is a continuous function, we can use the intermediate value theorem to guarantee that we cross a 0 or an x-intercept. And I drew it a little bit visually for you so you could see it if you're a visual person. But the intermediate value theorem is going to guarantee that we have all the output values between -1 and 13. So for part 3, I don't care if you write it fancy or not. What I'm looking for, what you're going to get points on, is that you're invoking the intermediate value theorem to guarantee that you have a 0. I have to see the word intermediate value theorem, okay? That's the key thing I'm looking for. So since we are below 0, and because that's the value we're looking for, and that since we are below 0 and we are above 0, so since we are below and above what we're looking for, the intermediate value theorem, and you can abbreviate this on the test, it's fine. IVT, intermediate value theorem, guarantees that there is at least one value of C such that f of c equals to 0. The intermediate, so this is a key thing I'm looking for on the test. The intermediate value theorem guarantees that there's at least one value of c such that f of c is equal to 0. In this particular function, there's just actually one value that equals to 0, but you have other functions that can, on the segment, they might oscillate up and down and cover it more than once. Now, if you want to do, I think, if you wanted to add, this is what I'm asking for in the test, but let's just see what this looks like if you try to solve it. So some people may want to solve it. It may just be a nasty number, right? You'd first move the 3, you divide off the 2. Yeah, so we'd need our calculator to actually find, you'd have to take the cube root of both sides. Yeah, we need our calculator to actually find the x value for that y. Alright gang, so this is the 3 steps I'm looking for. I'm looking for you to say the function's continuous. I'm looking for you to give me the 2 output values for y, and I'm looking for you to invoke the intermediate value theorem. Alright, hope that helped. Catch you. Bye-bye.